We are solving question number 31 of GATE 2019 Chemical Engineering paper. And the question is, choose the option that correctly matches the step response curve on the left side with the appropriate transfer function on the right side. The step input change occurs at time t equal to 0. And we have been given the options corresponding to this. Match the following. So over here on the right hand side, we have been given this transfer function, 4 different transfer function. And on the left hand side, we have been given the step response corresponding to the transfer function. And we have to find which one of the following plots belong to which of the transfer function. So let's take this step by step. So let's just consider this first transfer function. So over here, one is k upon zeta s plus 1 upon s tau s plus 1, where k is greater than 0, zeta is greater than 0, and tau is greater than 0. So to find the response corresponding to this transfer function for the step input, we have the step input u of s as 1 upon s. So we can find the response as y of s is equal to g of x into u of s, that will be 1 upon s into k times zeta s plus 1 upon s tau s plus 1. So one of the more complicated method to find the response is take the inverse of this equation, and then we will be having the relation between y and time, and then we can match which of the following option is matching. The other approach we can do is we can find the initial value and final value of all of this transfer function and then compare the values. Since in each of this plot you can see that the final value is differing and initial value is also differing. So let's just use this initial value theorem to find the initial value of this transfer function. So according to this initial value theorem, this y of 0, we can get it as limit s tends to infinity sys. So that will become limit s tends to infinity s upon s to k. Now from this term we will be taking s common. It is zeta plus 1 upon s upon s square tau into 1 upon s. So this will get cancelled out. Now we can replace the value of s as infinity to find the initial value. So that will become k upon s is infinity. So 1 upon infinity will be, that is zeta plus 0 upon tau. So basically this value will be 0. That is at time t equal to 0, the value will be 0. Now we can find the final value. That is at time t equal to infinity. What is the value? So we can find it by limit s tends to 0 sys. So we can just put the value of s as 0 in this equation. That is s into 1 upon s into k tau of 0 plus 1 upon s. We will be putting it as 0 tau into 0 plus 1. This will get cancelled out. So over here we will be having 1 upon 0, that is basically infinity. So when time t tends to infinity, the value of the output will also keep on increasing. That is basically we don't have a bounded output. So from the given option, we can see that in the first option, the value is becoming constant at some fixed value. In the second option, the value keeps on increasing with time. In the last two options also, the value will converge to some steady state. So that is corresponding to this transfer function given by 1, the plot is shown in this Q block. So that is for Q, we have the first transfer function. Similarly, let us do for the second transfer function. So for the second transfer function, the response will be 1 upon s k zeta s plus 1 upon tau s plus 1. Now for initial value problem, initial value, we can write this y of 0 as limit s tends to infinity s into 1 upon s k zeta s plus 1 upon tau s plus 1. This will get cancelled out. We can take s as common, so it will become ks upon s plus zeta plus 1 upon s upon tau plus 1 upon s. S will get cancelled out, and if we put this s as infinity, we will be getting the initial values k zeta upon tau. So over here we have been given that all these values are greater than 0. That implies that this value will also be greater than 0. Similarly, we will be finding the final value. It will become y of infinity, that is limit s tends to 0. Okay, so we'll be putting this as equal to 0, so it will become 0 plus 1 upon, again 0 plus 1, that is 1. This will get cancelled out. So the final value will be k, that is some constant. So the initial value is a positive value greater than 0, and the final value is also a positive value, that is the greater than 0. So in the first option, the initial value is 0. Second option also, we have been given the initial value as 0. In the third option also, the initial value, we can say it as 0. And in the last option, we can see that the initial value is some fixed positive value, and that the final value is also some constant k. That is the second option. The second transfer function will correspond to the plot given by this s. That is s is 2. So until now we have q equal to 1, s is equal to 2. Let's just write it over here. q1 s2. And the third transfer function, that is g of s is equal to k upon tau s plus 1. Now this, we can remember that this is the first order transfer function. So for the first order transfer function, the response is given by such a kind of plot, and this plot matches this option P. So we can write this as, or corresponding to P, we are having third option. Now let's just analyze this fourth option also. We don't need for the final answer, but let's just understand it. So in the fourth option, we have been given the transfer function g of s as k times of zeta s plus 1 upon tau 1 s plus 1 upon tau 2 s plus 1. So from the transfer function, we can see that we are having two time constant. That implies that there would be two interacting elements in this system, and also this transfer function matches the general transfer function form of this for this inverse response. So if any process is having components which provides us an inverse response, then the transfer function can be written as the form of k tau s plus 1 upon tau 1 s plus 1 upon tau 2 s plus 1. And if the zeros of this transfer function, that is the roots of the numerator, are greater than 0, that is, we can say that we are having an inverse response. And in case of an inverse response, what will happen is initially the response will be in one direction, and at the end the direction of the response will be another. So over here, if we have to find the roots of this equation, that is the numerator, that is zeta s plus 1 is equal to 0. We have this value of zeta over here is less than 0. So that is s, we can write it as minus 1 upon zeta. And since zeta is also less than 0, s will be greater than 0. That is, since the zeros of this transfer function is positive, we can say that this transfer function corresponds to an inverse response. Now from the given plot, this corresponding this option R, we can see that initially the output is negative and then it will eventually reach a steady state at the positive value. That is, this is our inverse response. So corresponding to this option 4, we have this plot of R. So R will correspond to this 4. So over here we can just write R is equal to 4. Now we will we'll select the correct option from the given MCQs. So we are having this sequence of PQRS, so that is 3, 1, 4, 2. Now from the given option, we can say that 3, 1, 4, 2 corresponds to this option B. So option B is the correct answer.